section E, the most highly securing, highly scoreable section in this part. This is having 3 questions of 5 marks each, and it will be in total 15 marks. So first of all, let me tell you, it will be mostly numerical based. Okay, there is no choice given. You have to attempt 3 questions, but there may be choices within a question, right? Say, let's say question number 25 has got 2 questions. In that, you can attempt only one, either the first one or either the second one. That within a question, a choice may be given, but you will not be provided with overall choices. This is what the CBSE has done. First question, question number 24, in the 5 marks part, 2 parallel rays with negligible resistance are 10 centimeter apart. Now see here, this is a diagram given. This is 10 centimeter apart. They are connected by a 5 ohm resistance. So they are connected by a 5 ohm resistor. The circuit also contains 2 metal rods having resistance of 10 ohm. We have 10 ohm and 15 ohm along the rails. The rods are pulled away from the resistor at a constant speed of 4 meter per second. This is pulled at a speed of 4 meter per second, and this at 2 meter per second and 2 meter per second respectively. A uniform magnetic field of magnitude 0.01 Tesla. So I am writing here magnetic field which is existing, that is 0.01 Tesla, is applied perpendicular to the plane of the rails. Determine the current in the 5 ohm resistor. If you want to find out what is the current in this resistor, that is what is required. Now how to do? First of all, these 2 rails are moving. Now we know that when a rail is moving in a magnetic field and the circuit is complete, that means it will work as a battery, it will work as a cell. First of all, let me show you, if this is moving, any rail is moving, if you remember, the EMF of one cell is given by BVL. So this magnetic field is given as 0.01. We have velocity given as 4 meter per second and length is given as 0.1 in meters. Now if you do this, you will be getting 4 into 10 to the power minus 3 volts. Let's say this is EMF 1, so I am writing this as E1. Now for the second part, so that is what we have done. As you can see here, we went to the further next question. Now see, this was the question. So we got this. Its EMF will be BVL, and that came out to be 4 into 10 to the power minus 3 volt for this. Now let's go with this. What will be its EMF? Its EMF will be BVL again. So E2, I am writing BVL 0.01 into 2 into 0.1. So 2 into 10 to the power minus 3 volt. We got this E1 and E2. This is what we obtained, 2 into 10 to the power minus 3 volt. Now, as they are moving, they are also having internal resistance. So if you draw an equivalent circuit, noting down these 2 values, we can draw an equivalent circuit of this. We will be having, this circuit will be somewhat like this. See how I am drawing the terminals, and I will tell you why I am drawing the terminals in this way, the terminals of the cell in this way. This is how the rails would be appearing. This is actually E2, that was 2 millivolts, 2 into 10 to the power minus 3 volt. This was actually E1. This is 4 millivolts. Why I have shown the terminals in this way? Before that, let us mark the particular ends. This is DC, this is AB, A, B, C, D, E, F. So what I am going to do, I am right here, A, B, C, D, E, F. Why I have marked this terminus in this way? See here, when it is moving towards left, this rail, just take your right hand, perform IL cross B. You will be having the idea of the potential, or what you can do, you can also use the formula QV cross B, how the charges are going to flow. If you use QV cross B, so positive charge is going to shift here. So this end will become positive, and here if you do QV cross B, you will be getting positive charge will shift here. So that's what I have marked, positive terminal here and positive terminal here. QV cross B you have to use, ILB is not used, that is for the force on a conductor when it is moving in, and current carrying conductor is moving in a magnetic field. Now that is placed in a magnetic field, so we are required to see by QV cross B. What you do, this resistance is given as 5 ohm. This resistance you see it's given as 10 ohm and this is 15 ohm. So 10 ohm and 15 ohm. Internal resistance of each of the cell. I am writing this as R1 and this is R2. Now can you think of, we are required what is the current in this part of the circuit, what is the current in this part. Now can you think of this and this cell are connected in parallel, so equivalent EMF, if you have learned this, two cells in parallel, this is actually nothing but E1 R2 minus E2 R1. E1 R2 minus E2 R1 upon R1 plus R2. This you will get as the equivalent EMF. So this will be how much? Substitute the value of E1. E1 is 4 millivolts. So 4 into 10 to the power minus 3 and multiplied by R2, that is 15. Multiplied by 10 to the power minus 3, that we will do later on. E2 R1. E2 is how much? 2 multiplied by R1, that will come out to be 10 into 10 to the power minus 3 divided by R1 plus R2, that is 10 plus 15. The method that I have applied here, I have applied directly. You have to check how to find out the equivalent EMF when cells are connected in parallel, and by that we have got this. From here 15 into 4 60, 60 minus 20 we got 40. So 40 divided by 25 into 10 to the power minus 3. Now easily you can obtain this. This value will give you, this will be 0.16. You see, yes, I can write here 400 divided by 25. This will give you 0.16 into 10 to the power minus 3 volt. We are going to obtain this. Now you see here, yes, this will be 400 by 25, 4 into 4 16, yes, 0.16. Next, we are required what is the current in the circuit. So what you have to do, you have to find out the equivalent resistance of the circuit, and for that you see here, to the plane of the rays determine the current in the 5 ohm resistor. Now the circuit will be somewhat like this. It will appear to us, we can eliminate this and you will be having one cell of equivalent EMF this, and the equivalent resistance will be simply you take this 10 and 15, they are both are in parallel. So equivalent internal resistance will come out to be, multiply both the resistance and divide by their sum. You will get this as 6 ohm. You will get this value, that is 6 ohm. Now current is simply net EMF equivalent divided by external resistance upon equivalent of internal resistance. This is the value 0.16 multiplied by 10 to the power minus 3 volt. R plus R, 5 plus 11. So we can write this as, this is actually 6, I wrote 11, this is actually 6. So we will get 16, can I write this 16 by 11 into 10 to the power minus 5 ampere. This is what we are going to obtain. So this will be the value of current through the resistance. So I want you all to take down till here and we'll start with the next question. Okay, so you would have taken down this. Now one thing, if you are pretty much aware what calculation we are doing, we got here the equivalent EMF as 40 by 25 and multiplied by 10 to the power minus 3. This will actually come out to be 1.6. I wrote 0.16. This is actually 1.6 into 10 to the power minus 3 volts. So you have to substitute here 1.6. Okay, take care of that. This will be actually 1.6 into 10 to the power minus 3 divided by 5 plus 6, 11. So this will be 1.6 actually, 1.6 into 10 to the power, change it here, this will become 16 by 11 into 10 to power minus 4. We will be having this as the required answer. The rest you can do here, it's quite easy from here. You can do here, this is the value of current. You can easily write down its value, it will be somewhat 1.5, then we will be having 4 something to 10 to power minus 4 ampere. This will be the value of current that will be flowing through the 5 ohm resistor. Let's go to the next question. So for this, in this question, why it is a 5 marks question? Because you should have the idea that each of the moving rail will work as a cell. Then you should know how to calculate the equivalent EMF of the cell. Even you can use Kirchhoff voltage law also, but that would be quite lengthier one. If you know to calculate the equivalent EMF, you will get this answer. Now in this question, I showed you this as positive terminal and we equated the equivalent EMF. Now current would be moving from D to C in this given circuit, because when we took this as reference, we got that this EMF as positive. That means this end will be working as the positive terminal and current will move along this in this direction from D to C. So current will move from D to C. You should even mention this in your answer. Let's go with the next one. Question number 25. Circular coil of radius 8 cm and 20 turns rotates about its vertical diameter with an angular speed of 50 per second in a uniform horizontal magnetic field of magnitude 3 to 10 power minus 2 Tesla. Obtain the maximum and average induced EMF in the coil. If it forms a closed loop of resistance 10 ohm, how much power is dissipated as heat? What is the source of this power? Now see, the variables given are circular coil of radius 8 cm. Radius 8 cm, 20 turns, capital N is equal to 20. Then we have rotate about its vertical diameter with an angular speed of 50. That is actually 50 radian per second. Okay, 50 in a uniform horizontal magnetic field of magnitude 3 into 10 to the minus 2 Tesla. Then we have obtained the maximum and average induced EMF in the coil. Maximum EMF and average EMF induced in the coil. If it forms a closed loop of resistance 10 ohm, how much power is dissipated? See here, if you remember, a coil is rotated, the EMF induced is given as N B A omega sine omega t. N is for number of turns, B is for magnetic field, A is for area of cross section, omega is the angular frequency or angular speed you can think of, and then we have actually the angular frequency, the number of turns per unit set time, into sine omega t. That is the value of angular frequency. It's given. Substitute the values. You have N as 20, magnetic field is given as 3 to 10 power minus 2 into area, that is pi into r square multiplied by, now I am writing this as E max, EMF max. For EMF max, sine omega t will be taken as 1. So area omega square and here 50. And we have taken, since sine omega t is equal to 1, this is what we have taken. So we have to take down these values. You can easily calculate this, you will get the required answer. What I will ask you all, I will ask you all to write the value of radius also. 20 into 3 will give you 60. 6 into 10 to power minus 1, this I can write, into pi, and the value of r is given as 8 centimeter. So 8 centimeter, so 8 into 10 to power minus 2 whole square multiplied by 50. You have to solve this and you have to reach on the value of equivalent EMF, and this can be easily evaluated if you note down this value is given as 3.14. So 6 into 8 into 8, 64, 10 to power minus 4 minus 1, so minus 5 multiplied by pi 3.14, and we are having here 50. I can easily solve this. I want you all to take down till here and I will give you the value. Okay, so I believe that you would have evaluated its value. Its value will come out to be 0.603 volt. In exam, you may get sometime a bit trickier calculation, sometimes you may get an easy calculation. So be ready to solve each step. So this we got the value of EMF max. Now the second part was maximum average induced EMF. Let me tell you, for one complete turn, the value of average EMF will come out to be 0, because in one cycle the value of sine omega t in one cycle is 0. Its average value of sine theta in one cycle in for 0 to 2 pi angle, that is theta, that is 0. So average EMF is equal to 0 in one cycle, so this will remain 0. This is the answer for average EMF. Next we are required if it forms a closed loop of resistance 10 ohm. Closed loop of resistance 10 ohm, that's given. How much power is dissipated as heat? So can we find out the current? The current would be simply, you see here, current will be maximum current if you want to find out, and this will be E max by R. This is 0.603 by 10. So you will get 6, I am writing here 6.03 into 10 to the power minus 2 ampere. So the power dissipated, you see here, power dissipated will be simply I square R. Right here, then take square of this, and then we have the value of R is given as 10. You can easily evaluate it. You will be getting this as, you can see here, 6 whole square, you obtain some value, you can easily calculate it. It will be somewhat 36 nearly. So I am writing here 36 into 10 to the power minus 4, you will be having 36 10 to the power minus 4 and plus 1, 10 to the power minus 3 in watts. This will be 0.036 watt. Or you can even write the answer from proper scientific notation as 3.6 into 10 to the power minus 1 watt. Yes, 10 to the power minus 2 watt. This is what you can do. 3.6 10 to the power minus 2 watt. You can also write the same answer in this way. So we got this. Let's see, we were required how much power is dissipated as heat. This will be the value of power. Now we have what is the source of this power. Now see, there will be an induced current in the coil as it rotates. Let me write here, as the coil rotates, there is an induced current. So induced current exists. This induced current will actually try to stop the rotation of the coil. It will actually try to resist the rotation of the coil, and hence you require a motor. You require a motor to keep the coil rotating. So we require motor to keep the coil rotating. And this power dissipated as heat, that will be supplied by this motor. So power is supplied by this external motor. This is how you have to see, because the induced current will have to try to resist the rotation of the coil, and to rotate that we require an external motor, and that will be giving the power required. Let's go to the last question of section E. When an alternating voltage of 220 volt is applied across a device X, a current of 0.5 ampere flows through the circuit and is in phase with the applied voltage. Current is in phase with the voltage, that means X is a resistor, that is quite clear. When the same voltage applied across another device Y, the same current again flows through the circuit, but it leads the applied voltage by pi by 2 radians. Now current is leading, that means Y is capacitor, we know that. Name the device X and Y. So we got that X is nothing but a resistor, and Y, see that same current again flows through the circuit, but it leads the applied voltage. When current leads, that means it's a case of capacitor, so Y is a capacitor. Calculate the current flowing in the circuit when same voltage applied across the series combination of X and Y. Same voltage, we want to know that 220 volt is applied. Now see here, In both the cases, when alternating current voltage of 220 volt is applied, device X, a current of 0.5 ampere flows through the circuit. So with this, we can find out the value of resistance. So the resistance value will be 220 divided by the value of current, R equals V by I, that is 0.5. It comes out to be 440 ohms. Similarly, the reactance of the capacitor will come out to be 220 divided by 0.5, that is 440 ohm. Now if both are connected in series, with the same source, calculate the current, combination of X and Y. We want to calculate the current, so current is nothing. First of all, can we calculate the equivalent impedance of the circuit? So the impedance will come out to be Z is equal to under root of R square plus chi C whole square. This will come out to be R square is 440 whole square plus chi C, that is 440 whole square. You will get 440 under root 2. This will be the value of the impedance. Now we want to find the value of current. So what you do is simply divide voltage by impedance. So the current in the circuit will be current V by Z. V is how much? 220. Z is how much? 440 by root 2. So we are going to get 1 upon 2 root 2 ampere current when both are connected in series. Now see, this was just a sample paper giving you an idea about the questions and the marking scheme of the examination. What I will request from you, just revise the entire chapter, revise the minute part of each chapter, see and practice questions. That would be very much helpful. Do see the sample paper solution, as we have solved the entire paper. You do practice more sample papers, which would be very much helpful. Also see the previous year's paper for your board examination that have been asked in previous year examinations, so that you will be having a clear idea of what examiner seeks from you. Till the time, do study well, do practice well. I wish you all the very best for your board examination. Do perform well, do come out with flying colors. Thank you everyone. Do wish you all the very best once again.